This conference will now be recorded.
Okay, I'd like to establish a quorum. Frank Thorwald,
Bill Feyerabend.
Stephen Cooper.
and we know Commissioner Nations is on the line but having problems. Dale, are you?
Brad Agraff with Rare Exploration.
Well, no, this is just the commissioners that are.
I'm sorry.
Establish a quorum here.
Sorry.
Dale, we know he's online, so this meeting comes to order. Any conflicts of interest? Okay, hearing none, let's move on to item 2, the approval of the minutes from the May 15th public meeting. Does anybody have any comments? Any changes? Do I hear a motion to approve those minutes?
This is Bill. I move we approve the minutes from the May 15th public meeting.
I second that motion.
Stephen Cooper.
Thank you, Stephen. All in favor, say aye.
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 Any opposed? Hearing none, the public meeting minutes are approved. Let's go on to the public hearing meetings for Desert Mountain Energy spacing exception. Is there any changes? Hearing none, do I hear a motion to approve?
I move we approve the minutes for the Desert Mountain Energy public hearing. Bill?
This is Stephen Cooper. Second the motion.
Thank you. Having a first and a second, all in favor say aye.
Bill, aye.
Aye.
Frank Thorwald, aye. Stephen, was that you?
Yes, it was.
Okay. Let us move on. The meeting minutes for Desert Mountain Energy have been approved. Let's move on to item number 3. We have a guest today. They have been, Todd has been very nice to present for us on well cementing. He is with Halliburton, and we're going to really enjoy his presentation. They've been very good to work with. Todd, please introduce yourself.
Thank you, Frank. My name is Todd Enninga, Director of Government Affairs for Halliburton. And we are pleased to be here in front of the Commission and guests to talk a little bit about cementing well principles. My colleague, Simon Turton, who's on the line, I hope I pronounced your last name right, Simon. He's our Global Technical Advisor and is an expert on cementing well principles. And he is actually going to lead us through the presentation. And at the end of the presentation, Frank, if there are questions, I would direct them towards Simon, technical questions, because he, frankly, is going to be the one to be answering them. And with that, if we're ready to go, I'll turn it over to Simon.
Todd, thank you very much for that introduction. What I'll do first of all is say thank you to the Arizona Oil and Gas Conservation Commission for asking Halliburton to present us some of our cementing solutions. As you can imagine, it's a pretty wide portfolio and we only have a certain amount of set time this afternoon. Appreciate keeping questions to the end. Just a little bit about me. I am a member of the American Petroleum Institute Subcommittee 10, member of the Society of Petroleum Engineers, have been with Halliburton for 32 years and had the pleasure of working in 24 different countries throughout the world. So a little bit of experience there. Who's controlling the slides?
I'm controlling them, so just let me know as you want me to advance. Just say next and I will go ahead and advance for you.
Thank you, Marta. So please advance. And could you put it in presentation mode? I think it will just make it a little bit bigger on everybody's screen. Thank you. Perfect. Thank you very much. Okay, so a little bit about the history of cement. It was first of all discovered by the Romans, and they obviously built viaducts and some of the more exotic buildings out of a volcanic ash that they called pozzolan. And it was called pozzolan because it came from a town near Mount Vesuvius, which is very, very well known as well. And the town's name was Pozzolai. However, this kind of knowledge of construction and pozzolanic materials was actually lost with the fall of the Roman Empire. And on the right-hand side, there's a photograph of the Pantheon, which was constructed of cast concrete back in 125 AD. So move forward, please. So after the Roman Empire fell, that knowledge was pretty much lost until 1824, when Joseph Aspdin, a stonemason from Leeds in the UK, started to combine some raw mined materials together, and he discovered Portland cement. And that's because the raw products, it actually got its name because it came from a place called Portland, actually in the United Kingdom. And they heated limestones and clays, and they came across a product which, when combined with water, produced something which they were able to form into building blocks, roads, etc. But that wasn't until 1824. Move, please.
Simon, Frank Dorwald, you've got an echo that's making it hard to hear. I don't know if you can do anything about it or not.
Let me try and sit in a different position. Is that a bit better?
Can you hear me now?
Yes.
Very good. If we could move on to the next slide, please. Thank you.
I apologize.
Perfect. So why do we cement oil and gas wells? We drill a hole into the ground. We then run in a piece of what we call casing, which is metal pipe. And then we actually place a cement in the annulus, which is the area between the open reservoir face and the external of the metal pipe ran into the hole. That's called the annulus. And we do that to restrict fluid movements. Obviously, different zones have different pressures. And with those differences in pressures, you can have fluids, whether it's gas, whether it's water, oil, moving from one zone to a different zone. And hence, the primary reason is to go ahead and provide isolation of freshwater aquifers from some of those other areas that potentially could pollute that fresh water that a city or a township may rely upon. By cementing that metal pipe in place, we also form part of a construction process by which another smaller piece of metal pipe can then be run inside that existing pipe as another section of hole is drilled. And then that can be cemented in place as well, again, providing restrictions, pressure restrictions, and fluid restrictions. We quite often drill through areas that may have carbon dioxide, that may have salts, that may have hydrogen sulfide. And those are just three items that can actually corrode that metal pipe. So by inhibiting any kind of fluid movement from the reservoir to that pipe, we can extend the life of the well by reducing corrosion of those metal tubulars. We also are able to control the pressures as we drill. It would be very nice just to drill a single size hole from the surface to the desired depth and run in one piece of pipe, one size piece of pipe back to surface and cement it in place. But we find that nowadays we get into more of a telescope type of well construction. It looks like a telescope if you hold the widest diameter at the top and then the smaller tubulars as we go down like a telescope that's upside down. And we have to seal off certain loss formations, certain areas that have low fracture, high porosity, high permeability, because once we have the drilling fluid in the well, we don't want to lose that, because loss of that drilling fluid would mean that we can no longer keep a hydrostatic when we reach the desired or higher pressure areas. So it's important that we do have control as we drill that well at all times. Next slide, please. I was asked to talk a little bit about the types of cement. In the US, we do run A's, Class A, Class C, Class G, and Class H. Those are API, American Petroleum Institute classifications. You can also see in the table on the right-hand side, there is ASTM, which is more, let's say, the construction language, the civil engineering language. And you could compare some of those A, B's, and C's, which are common construction cements, but they have limitations. So people would normally say that Class A's, B's, and C's would be used for depths of less than 6,000 feet, and they would be used at temperatures less than about 170 Fahrenheit. And that's because they are really construction cements and quite often contain accelerators, so that the construction industry, when they're building something, don't have a lot of unproductive time as they wait for the cement to harden. The common ones that we use for oil and gas cementing are really the G and H. And they have what we call moderate sulfide resistance. In the first column, you can see sulfate resistance. And it's important that for drilling oil and gas wells, we have sulfate resistant cement, as that in itself will corrode. And obviously we want to protect the metal tubulars from any kind of corrosion. So G's and H's are the normal ones that we use. G is a finer grind. In fact, I've used more G globally than anywhere else. And then there's a couple of quite exotic cements, which are E and F, which really you need to consider where you're over 260 Fahrenheit or more. But that doesn't mean we can't use G and H at that temperature. You might just put a lot more additives in there so we don't have cement retrofit.
Hi, this is Dale. I'm connected by phone now.
Sounds good, Dale. Thank you.
But I'm not sure what's happening on the screen. I'm looking at the presentation, cement presentation.
Next slide, please.
Sorry, forgive me. I just wanted to make sure Dale could hear what you were saying.
Thank you.
No, now I can hear you, but I can also hear me. So I need to mute my computer.
Yes.
Okay.
Sorry for the interruption.
How about that? Okay, I muted my computer, so now I'm just hearing me.
Okay, can you hear me still?
Yes.
All right, let's see if this works. I guess we can continue.
Thank you.
Well, I can just go verbally. You don't need to worry about. I've got the presentation on the screen, but you're not doing that yet, are you?
Yes, we're already in the middle of the presentation.
Oh, okay. Well, then probably I'm okay. I'll just be quiet.
Okay. You might want to mute your cell phone as well if you've called in on that.
What?
You mute any devices you're called in on.
Okay.
Okay.
All right.
So now that we've discussed the main classes of cement, we're going to talk a little bit about some of the more specialized blends of cement. And the first one of those I wanted to talk about is one that we call POSMIX. It's a pozzolan Portland blend. And pozzolans are obtained, it's a byproduct from coal-fired power generation. And fly ash in itself provides some additional properties to the cement, which are very attractive for oil and gas field construction. The strength retrogression at higher temperatures. Now, a Portland cement will actually degrade above 230 Fahrenheit, and it undergoes what we call retrogression, where the cement actually forms in different materials, and those materials that are formed through a function of that high temperature create weakness in the mechanical properties. So it weakens it, it possibly can crack. So we would normally add something which contains silica. This byproduct does contain silica, and hence it can provide additional strength retrogression properties, which are always attractive. And being a byproduct as well, that means it doesn't have to be disposed of. It's a byproduct which doesn't create an additional waste chain. It can be incorporated into additional construction. Next slide, please. Wanted to talk a little bit about foam cement. Foam cement is fairly unique in itself because it tends to be lightweight. We can pump foam cement that even is lighter than water, so it actually float on water, so less than 8.3 pounds per gallon. The way we do this is we take our cement, we mix it with water, so now we have that wet slurry. In the slurry, we then have a surfactant, and as we pump the wet cement with the surfactant, we inject nitrogen into it. And that nitrogen is injected at a pressure where it actually foams. It looks like, if you can see the picture on the screen, it looks just like shaving foam. And we design the slurry for stability, for the specific density, and the foam is compressible in its nature, which means that it's very, very good at sealing off any lost circulation zones. And because we're not lightening it up, adding water, because we're adding a gas to it, it means that it actually has better mechanical properties than a normal cement as well. Additional properties it can have are it's very good with thermal insulation, so in high temperature wells, if you're worried about tubing stretch or pipe stretch, it's very good at thermal insulation, loss circulation, mechanical properties, meaning compressive strength, tensile strength as well. So foam cement is very applicable, not in every situation, but in certain more challenging situations where you want to cement. Next slide, please. Corrosive environments. Now, I know I got asked to talk a little bit about this. So what happens when CO2 reacts with Portland cement? Well, it does, and it does if it's wet. Dry CO2 is not too much of a problem unless it contacts your tubulars, but a wet CO2 makes what we call a carbonic acid. And it's that carbonic acid that attacks the cement itself. And by attacking the cement, it actually weakens the cement. And hence, in a CO2 environment, a wet CO2 environment, there are certain things that we look to do. And one of those is to reduce the permeability of the cement, so the gas can't actually go through it. And we normally look at latexes and things of that nature. Next slide.
Not allowing me to stay in presentation mode for some reason. So I'm just gonna try to do it this way. Let me know if this is an issue.
Appreciate your help. Thank you.
Okay.
So minimizing, because Portland cement in itself will weaken in the presence of wet CO2, the carbonic acid, one of the things we can do as well is to reduce the amount of Portland cement in the blend itself. So we can substitute a percentage, instead of having 100% Portland cement, water and additives, we can maybe have a 70% cement, 30% substitute material that is inert in the presence of carbonic acid. And hence one of the things we also look to do is reduce the amount of Portland in the cement. I did mention a little earlier the use of latex for permeability reduction of the cement. We would normally see about a 0.1 millidarcy on a 15 pound per gallon cement. And if we further reduce that, it would inhibit the carbonic acid actually invading the matrix of the set cement itself. In extreme conditions where we have very high CO2, wet CO2, we actually have a selection or a series of products which contain no Portland cement at all. And you can see the bottom bullet on that page references a product called Thermalock, which is a very, very temperature resistant, CO2 resistant, H2S resistant, salt resistant slurry. And that's because it doesn't contain any Portland at all. We've ran Thermalock as inherently in its name, it sounds as though it's got something to do with temperature, and we can actually run that at temperatures over 1000 Fahrenheit. So it's very, very inert. Next slide, please. Salt environments. So we see a lot of salts, and we try and categorize the salts that we drill through, whether you're in the North Sea, whether you're in Brazil, the Middle East, the Gulf of Mexico, or US land. You quite often come across salts, and we categorize them really into three main categories. One is a static salt, and that is where it's immobile. And our biggest concern when we cement across a salt section there is that we will dissolve the salt with the liquid cement and liquid spacer and program that we pump to cement the well. We'll actually dissolve some of that salt. And of course, if we dissolve the salt, we now have salt in our cement slurry. And sometimes that doesn't play very well together. Salt is inherently an accelerator, and we can get flash set cement. By dissolving the salt, we've now made the annulus area we're cementing bigger because we've dissolved some of it. So we have some different ways and technologies to be able to do that. Now, plastic salts, the second category, are where they are mobile. And the issue we come across here, if we dissolve it, it's not so much of an issue because it's flowing. It'll move back in and fill up any microannuli or area that we may have dissolved. The issue we have here is the stresses that they will impose upon the cement sheath in the annulus and the tubulars inside the well. And we have a program called Well Life, which is a finite element analysis program that actually allows us to model and come up with the mechanical properties that we would need for the cement to withstand resist the stresses that flowing salt may impose on the annulus. The last one that we have here, the last category, are overpressured rafts, polyhalite salts. There's one that we came across that's a magnesium-based brine or magnesium chloride, which is what we'd classify as a tachyhydrite as opposed to a halite. And there's two issues we have here. Is a magnesium brine will contaminate the cement, and we get a chemistry resulting reaction called brossite. And the brossite basically makes it so thick that it almost becomes immobile, and we mostly won't be able to finish placing the cement. It'll lead to an early termination of the job. Next slide, please.
I was trying something to see if it would fix the problem, but it doesn't seem to be working.
That's okay.
Just the way it is.
Thank you. So one of the things we can do when we cement through static salts is actually to introduce some salt into our cement slurry as well. And there's different salt between 1 to 10% will actually accelerate our cement. So it means we reduce the thickening time. The length time it is liquid is reduced. And that can present some challenges in itself. If you go too much salt in your cement slurry, you can reduce the compressive strength and it'll retard it, meaning it'll take a lot longer for it to actually set up. I can't see the screen, but I can pull it up on my computer. So if we're running, that's okay. So if we're designing for static salt, we would normally look about 10 to 18% by weight of cement sodium chloride. Somewhere between 1 to 10% will accelerate. Anything over 18% will delay. It'll be liquid for days, possibly longer. And hence we would look at about 10 to 18% by weight of cement sodium chloride incorporated into the cement, which by incorporating it into the cement slurry means that you're not going to dissolve it as you go past the static salt because it's already about the same concentration. Once again, the fourth bullet point there, if you've got tachyhydrites, magnesiums, magnesium chlorides, they are very unpredictable in the presence of cement and can lead to hydrolation and possibly flash setting of the cement. So magnesium chlorides need to be dealt with slightly differently. And we have a product where we would introduce called Salt Shield to be able to cement through a tachyhydrite, a magnesium chloride situation. So really the salt, to analyze the salt that you are going to be cementing through, to get a sample and run it through the laboratory, XRD, X-ray spectroscopy, and understand its chemical makeup so that we can choose the right solution would be highly recommended. Next slide, please. An alternative to running sodium chloride is to run potassium chloride. The nice thing is it's a lower concentration. Instead of the 10 to 18%, we're only having to add 3 to 5% by weight of cement. The properties in terms of the set time of the cement, the fluid loss, is a lot more predictable than using sodium chloride as well. And because you have the chloride in there, again, you're not going to be able, or you won't be dissolving the static salt and leaving any microannuli, because you've already got this chloride in the slurry. The other thing with potassium chloride, if you're in a shale area, if you're drilling through shales, it's also a shale inhibitor, meaning that it'll provide anti-swelling, anti-stick, and annular bridging issues. It'll help control that as well. Next slide, please. Okay, move on to a different section now. Next slide, where we're actually going to look at some of the challenges. One of the biggest challenges that we see globally are clients tell us they experience sustained casing pressure, annular pressure buildup, where on one of the annuli, after a few days or a few months after, they now have pressure building, which leads them to a lot of countries, the regulatory authorities won't allow you to produce from a well with sustained or annular casing pressure, which means that they have to do something about it. But maybe what's even more important than knowing what to do about it is try to ensure that you're not going to get it in the first place. Next slide, please. So there's we categorize this annular pressure buildup into two categories. There's a short time where the hydrocarbon, gas, oil, maybe even water flows through the unset cement. And then there's a longer term where the hydrocarbon will flow through mud channels in the set cement. Next slide, please. short term is where we have a potential loss of overbalance pressure. And this loss of overbalance pressure, obviously a column of fluid exerts the hydrostatic pressure. But as that fluid goes from a fluid to a solid, that hydrostatic pressure gets relieved. And through relieving the hydrostatic pressure, you then have a point at which you potentially could have migration through the unset cement. Next slide, please. Longer term is normally where you'd say a couple of months afterwards, and if you haven't been able to displace all of the drilling fluid out of the way, then a dry gas would dehydrate the filter cake and provide microannuli for fluid gas migration. And another thing here too, cement inherently shrinks. So cement will shrink by 1 to 2% in volume. And when we design a cement job, so consider, do we need to put an additive into that design that counteracts, it doesn't necessarily expand, even though we call them expansion additives, but it eliminates the shrinkage, because if something shrinks over a period of time, then it's not filling the area that it was initially filling, which could give you an annular pressure buildup. Next slide, please. Next slide. So the types of annular gas migration you can have through mud channels, through microannuli, through cement permeability, and through unset cement as well. But the leading cause of poor cement jobs globally is poor mud removal. So one of the most important things when we design a cement job is take the time to not just look at the cement itself, but to see how well can we displace the drilling fluid ahead of the cement and prepare the reservoir and the OD of the piece of pipe that we're cementing in place to water wet the environment so we can have a good bond. Next slide, please. We have a best practice we teach all of our engineers and staff, and it's really CAMPS, C-A-M-P-S. And this is the best practices for cementing. C is centralization. That is how well the piece of pipe you're cementing is positioned inside the open hole. The more centralized it is, the better you are. If it was to one side, then you would have a narrow side and a wide side, and cement, being a lazy fluid, will always go up the wide side, leaving the narrow side uncemented. So centralization, we would normally look for a standoff of 80% or more, meaning 80% of the pipe is perfectly in the middle of the hole. The next one we look at is annular fluid velocity. The faster you pump, the more turbulence you create in that annulus, and the more efficient you are at displacing the fluid ahead. Mud conditioning is very important, and conditioning covers the area that it needs to be the right properties that we designed the cement job for. If the properties have changed, meaning the yield point, the plastic viscosity, we might be ineffective at displacing it with the fluid that we brought out. And we also need to condition the well, which is 2 times bottom-up volume, circulate that volume to make sure that we've got all of the cuttings out from drilling the well prior to replacing the annular volume with cement. We then talk about the P of CAMPS, which is pipe mechanical aids, and that really is movement of the pipe. And we have 2 things we can do. We can either reciprocate, which means pull it in and out of the well as we cement, or we can rotate it at a speed of maybe 25 RPMs. And by rotating the pipe, we are further creating a turbulent environment, and we've done computational fluid dynamic simulations to show that it's very effective technique to do to displace the mud ahead. So camps, very, very important. The S of camps are spacers and flushers, and where we see a lot of synthetic or oil-based muds, we see different water-based muds. It's very important that we choose the right spacer package, which is, we pump the spacer in between the drilling fluid and the cement, and it's really the spacer's job to clear that mud out of the way and leave it in a water-wet environment for the cement to adhere to. Next slide, please. Microannular flow says, you know, some best practices on the right-hand side, and I think in the interest of time, we'll just focus upon those. After we cemented, we should avoid drilling out or pressure testing at the wrong time. We can do it as soon as we bump the top plug while the cement is still liquid, or then we have to wait until it's gone solid, and we'll see why in a minute. We need to include expansion additives, and if we're worried about cement shrinkage, we can do shrinkage testing in the laboratory. And similarly, we can do expansion testing in the laboratory, but we don't really look for too much expansion because it can be detrimental. We just look to counteract the shrinkage. So we have zero expansion. We look at compressible cements. We can look at high early strength cements, depending upon what the conditions we're cementing in. Next slide, please. Next slide. So this is kind of an important part to understand. Cement doesn't go from being a liquid to a solid instantaneously. If you look along the top, we have that fluid stage, and while it's a fluid, it's able to exert full hydrostatic pressure on the formation, keeping it under control. We then start to lose hydrostatic pressure on the formation as the cement goes through a plastic stage where it starts forming gel strength. That is an area that we need to analyze in the lab. And if we're worried about flow through the annulus, then we need to keep the time that it's a gel or a plastic stage to an absolute minimum. The cement then is set, but once it's set, we should be fairly comfortable that nothing will flow through it at that point. We have something labeled here where the hydrostatic pressure becomes equivalent to the formation pressure. We call that point the critical static gel strength of the cement. Next slide, please. So while no gas flow, the area on the top left-hand side of the slide is while we're a liquid. We then moved to that plastic stage, which is the pinky red color, where we have the potential for gas flow or hydrocarbon flow or water flow. And then we have the area where we call it solid, where it's no gas flow will occur. The two items here, the pink or red area in the middle is the area we need to be concerned about. And we measure that in the laboratory on a machine, and we call it the time period from 100 pounds per 100 foot squared to a static gel strength of 500 pounds per 100 foot squared. And laboratory testing has shown that once it reaches 500 pounds per 100 foot squared, it's considered solid. Nothing will flow through it at that point in time. API, the American Petroleum Institute, gives a guidance of 45 minutes or less. And we would normally laboratory design, if we're concerned about a flow potential factor, around about 30 minutes, no longer than 30 minutes to get us through that plastic stage, meaning we go from a liquid to a solid within 30 minutes. Next slide, please. We have a way to calculate this. In Halliburton, we talk about what we call a flow potential factor. And the previous graph, we saw static gel strength 100 to 500, which was the transition time. But we can actually calculate the hydrostatic loss of pressure due to the static gel strength development. And the formula's there, I won't go into it. Next slide, please. We're actually able to predict whether there will be hydrocarbon flow. Next slide, please. And that previous equation you just saw is MPR, the maximum pressure reduction. And if we divide that by the overbalanced pressure, which is the hydrostatic pressure minus the pore pressure, we come up with a number. And that number we consider to be in the range somewhere from 0 up to a potential of 14. So it's an integer, it's dimensionless. And by calculating up the flow potential factor, we're able to categorize the amount of concern associated with annular flow. Next slide, please. So we categorize, if we look at the slide here, anything 0 is negligible, no concern. We need to start to be concerned when we have a flow potential factor of 1 to 4. That's minor. We need to be more concerned when we get to moderate, which is 5 to 7. If we get to 8 to 15, that is severe. And anything really over 15, we need to be able to go back and redesign the way we're doing the cement job. Next slide, please. So flow condition 1, we would design our slurry to have a very, very low fluid loss of 50 cc's per 30 minutes or less. And that'll enable us to maintain instead of the fluid leaking off into the permeability of the reservoir, the open reservoir that we're cementing up against. It'll hold the fluid inside the cement and it'll be able to give us maintaining the hydrostatic pressure on the formation. Next slide, please. If we go to moderate, we would look to reduce that fluid loss even more, down to 25 cc's per 30 minutes. But we would also talk about the transition time, that static gel strength period between 100 to 500 pounds per 100 foot squared. We would want to have 30 minutes or less. Next slide, please. When we get to severe flow potential factor, there's really nothing we can do with fluid loss, transition times. Yes, they're still important, but there needs to be additional considerations to the slurry design as well. And that will include what we call a compressible system. Here we have, such as the foam cement I talked a little bit about earlier, that's what we would call a compressible system. It's able to maintain pressure on the formation, and obviously any volume changes through loss of fluid loss and those kind of things can be counteracted in the inherent nature of the foam because it will replace the volume that's lost. Again, we would look at transition times, but when we hit the severe condition, we need to be looking at foam cement. It's interesting to note that we also have an additive that we can incorporate into our cement that generates gas in situ. So in the absence of being able to take the nitrogen equipment to location, we're able to incorporate an additive which reacts with the cement and the water to generate gas when it's inside the well, which again, it will be trapped inside a surfactant and it will give us a compressible system. Next slide, please. I'd also got asked to talk a little bit about plug and abandonment design. This is an area that we have done a lot of plug and abandonments around the world. There's a few best practices here. I tried to put the best practices on the left-hand side, which are the bullet points that we're looking at. A non-shrinking design, if you're setting a plug inside a pipe, I talked about cement shrinkage. We need to ensure that we have an expansion additive in it so it doesn't shrink and leak. We also need to ensure that we put the plug, the cement plug, on a base. Now the base could be the bottom of the well, the bottom of the rat hole. It could be a mechanical plug that we put in the well. It could be a polymer, a viscous polymer that we put in there as well. But plug base, if you don't have a good plug base, the plug mostly won't be there when you go back in to test it. Stinger size is we normally put a small diameter pipe on the end of the work string so that when we pull out of the plug, having pumped the plug, we create a minimal of disturbance to it, and hence the contamination is kept minimal, and it still has the desired properties. Fluid separation is very important. We run foam balls, wiper darts through the work string to keep the fluids separated so that they don't become contaminated. We actually have plug setting tools where we pump the plug below the tool, and there is no string to retrieve. We leave that tool in there with the cement plug below it, and hence there is no stirring of it. There's no keeping contamination to a minimum. Displacement calculations are very important, such as temperature. Quite often people go back in and don't find the plug, or it's still soft, and that's because the temperature calculations that the calculator they've used has not provided them with an accurate temperature, so that's very important. And we also need to understand, are we restoring to caprock, and some of the tools that are used for that to mill through or perforate through the ABC annuli, clean the cement out from behind those annuli, and then replace with a single plug across. So if we need to restore caprock, we have techniques for doing that as well. Next slide, please. Next slide. Our main design engine, the main tool our engineers use globally, is called ISEM, and it's a predictive service design tool. We have two-dimensional hydraulic simulations, meaning equivalent circulating density, surface pressure, surge and swab, torque during rotation. And then we have 3D simulations, which you can see on the right-hand side. In fact, if you click, it is actually a video, and it does play. So if you just put your cursor, thank you. So we'll just let that play. This is a 3D simulation. We now have the spacer, which is the brown fluid displacing the mud. It's coming down the inside of the pipe. The yellow is a lead cement, and then we'll start and see the tail cement in a minute as well. And this is what we call a 3D simulation. It's performed by computational fluid dynamics, and we're able to optimize the amount of spacer and the densities and the rheological properties of the fluids to ensure efficient mud displacement and replacing the annular cement or the annular fluid with cement. As you can see in the middle top picture, the pipe is not very, the white thing is the casing, and then you can see the colored perimeter around the outside. That's the annulus. If you look at the very right-hand graph, you can see the blue channel that has been left, so of mud that we've been unable to displace. So in such a case, we may look at increasing the standoff, we might look at different fluid properties, and incorporating some of the rotational aspects of the pipe we talked about a little bit earlier. We're able to do casing stretch simulations on some of the wells drilled nowadays. They are much longer and they're much hotter, and we can see pipe stretch on a 25,000 foot 7-inch casing at 260 degrees. We can see pipe stretching up to about 80 foot. So if the pipe stretches during the cement job up to 80 foot and buries itself in the end of the well, that could mean the end of the cement job prematurely. So stretch is a very important thing to simulate and understand. We're also able to do a predictive bond log, and we are also able to look at stresses in the cement, but we really use a different program for that. We do run a dynamic temperature model. We don't run off API specifications for temperature nowadays. Those were written many years ago and have been superseded by dynamic temperature models. We have our own built into ISEM, and we actually use the temperatures predicted from the first sack to the last sack for the laboratory testing as well. Next slide, please. The other main design tool we use is a program called Well Life. And Well Life tells us it's a finite element analysis program, and it analyzes the stresses on the annular cement for the life of the well. So if we were going to produce high temperatures, if we were going to continue drilling with a much higher density fluid. All of these exert pressures on that cement, which we didn't know about before. Additionally, if you're going to perform multiple stages of fracturing through those tubulars, it's going to have a lot of cyclic stresses on it, and hence we're able to determine the mechanical properties such as compressive strength, tensile strength, Young's modulus, Poisson's ratio, friction angle, to be able to make sure that the cement is not going to fail and we can provide a long-term barrier for the life of that well. It's a very complicated program, but it gives us some very good guidance on more challenging condition wells. Next slide, please. So we have a full suite of cementing products. We have additives that will viscosify, meaning thicker, make them go thicker. Very important. As temperatures of fluids rise, we can see settling and obviously viscosifying. If you're going to be running heavyweight additives in your slurry, we don't want any settling to occur. We want it all to stay nice and homogeneous until it goes solid. We have expansion additives. We talked about those. Accelerators that reduce the thickening time, so that would keep it liquid for less time. We have retarders that keep it liquid for a longer time. Extenders are what we call lightweight additives. So we have a series of those. Foam and nitrogen is a lightweight additive. Hollow glass spheres is another example of an extender. Bentonite as well, which is commonly used in the oil and gas industry, is also an extender. Densifying materials, where we're able to go up to 24 pounds per gallon in terms of fluid density. We have a series of those, and once again, it depends upon the temperature environment and the final mechanical properties you want. Bayrite is a common one of those, for an example. Lost circulation materials have come a long way in the last couple of years. We actually have a computer program now, which will be part of ICEM, which enables us to optimize the concentration of lost circulation material in our spaces and cements to be able to control losses without plugging up any of the flow restrictions. We have defoamers. Cement has a habit of, when we blow the cement into the water as we mix it with the surface equipment, has a habit of air being entrained in it, and we need to knock that air out of it because that'll change the density of it. So we have defoamers, friction reducers, meaning that we are able to pump the cements faster, which creates turbulence and better mud displacement. Fluid loss control, so that we don't lose that hydrostatic in specific situations and create hydrocarbon channels to surface. Free water, again, that's really a viscosifying agent to keep everything homogeneous. We have anti-gas migration additives to be able to control gas going through. That's the additive that we would include that generates gas in situ as opposed to adding it on surface. And we also have a portfolio of additives that are self-healing. So a self-healing additive is if the cement did fail, then it would allow interventionless remediation of the cement sheath, meaning it would automatically repair itself. And we have a series of those, again, depending upon the environment you'll be in, oil, gas, water, and the temperature that you'll be cementing at as well. Next slide, please. Laboratory testing, I think everybody's familiar with that. It covers all of the properties that we would need, and all of the lab testing we do, every single one of those tests is actually entered into ICEM, and it's used as part of the design and the proposal for the cement work that we do. Next slide, please. And that pretty much wraps up the presentation today. So once again, thank you to everybody who joined the call. And if there are any questions, I'd be very happy to answer them at this time. Thank you.
Commissioners, if you have any questions, please direct them to Simon. Remember to unmute.
That might have been my telephone. Hello?
Go ahead, Commissioner Nation.
Yeah, this is Dale Nations. Can you hear me?
Go ahead and ask your question, Dale.
Yes.
Yes, we can hear you.
Hello? Hello?
Dale, go ahead, Dale. We can hear you.
This is Dale Nations. Can you hear me?
Yes, we can, sir.
Well, I don't know what's wrong. I've unmuted myself, but I guess you can't hear me.
We can hear you.
Well, in case you can't hear me, that was very impressive presentation. And I have no doubt Halliburton knows how to resolve any problems that they run across. And I'm just wondering if much of that relates directly to petroleum production, gas or petroleum directly, and would not relate directly to the gases that we're dealing with in the Holbrook Basin directly. That's my question.
This is Commissioner Thorwald.
So otherwise, if you can't hear me, I'll just log out.
Here in Arizona, we have CO2, we have helium, and then on tribal lands, we also have natural gas and oil, but we control the other areas. And we have in that particular area a very high salt content.
Hello?
So,
Hello?
for a little background before you answer that question, Simon.
Yeah, thank you for that. So, answer to the question, gas environments, yes, it's very important. Gas will permeate through cement faster than potentially oil will, certainly cement. It has an affinity also to dry out any filter cake which has been built up and not removed before the cement was put in place and create a microannuli. So gas well cementing, whether storage or production, really presents a lot more considerations than let's say an oil well would do. So yes, we would have to apply best practices, which was the camps, and in addition, your cement shrinkage, the filter cake and mud removal, and the annular barrier that we put in place would be critical components of achieving integrity. Thank you.
Commissioner Firebrand, do you have any questions? This is no questions. Okay. Commissioner Cooper, any questions?
I have no questions.
Okay. AG Skelton, is it okay for me to ask if any of the DEQ people are online for them to ask any questions?
Yes, it is. It's fine.
Is there anybody from DEQ that has any questions online? That's the Department of Environmental Quality. Anyone from DEQ that wants to ask anything? I don't hear anyone. Let me ask, I have a question myself. We have, as I mentioned earlier, a very high salt content in the water here. Is there any specific things that you have to do for an ultra high salt content? I understand you were talking about salt in different areas, but if it's very high, higher than you find in the ocean, how do you, is there anything special you do to deal with it?
Yes, just one question, if I may, regarding that. Is it a water, an aquifer, which is high salt content?
That is correct.
So what we would look to do is, first of all, analyze the type of salt, whether it's halite, polyhalite, whatever it is. And with that understanding, we would then miserably look to reduce the permeability of the cement such that we are able to protect the metal tubulars from any kind of corrosion. Latex additives, anything that reduces the permeability of cement to protect those tubulars is going to be very beneficial. We need to understand the pressure of that aquifer so that we can maintain a hydrostatic on it so that it doesn't impede the annulus during the plastic stage. But I would look for zero shrinkage cement and very, very low permeability cement such that we're able to keep that aquifer away from the metal tubulars. Thank you.
I have a follow-up question with regard to the tubular coatings. Do you recommend any particular tubular coatings on the tubes that are used to protect them both from the corrosion and from acid?
Yeah, I think we don't supply any of those myself, so I'm not really an expert at it. The only one I've ever seen is there was a coating co-developed with one of the large oil companies from a startup company in Hawaii that placed a coating on the outside of the pipe that made it desire water. So if it had been in an oil-based mud environment, as soon as it see water, it would repel the oil and it would want the water. And that had some case studies that showed better bonding of the cement to the metal tubulars, but I'm not that familiar with the other casing coatings. Thank you.
Do as Administrator Turner or Houghton have any questions for our guests?
Dale's back. I can hear what's going on now. This is Dale.
Okay, Dale, do you have any further questions?
I'm not sure where I was. I just wanted to say that was very.
They previously answered your question that you posed, and we'll get you that answer. But do you have any?
Okay, well, I'll leave it at that.
Okay, Administrator Turner.
I have no questions.
Okay, go ahead.
No questions.
No
Marta?
questions from me either. Thank you, Frank.
Certainly. Simon, I certainly want to thank you for that.
This is Bill. I've got a question. I'm sorry.
Oh, great. Go ahead, Bill.
Okay, so thank you very much for the presentation. It's really interesting. I'm kind of thinking, you know, if we take this information, if there's, you know, part of it is that you're dealing with, you know, we deal with different companies, with small companies, particularly with different, how can I put it, experience levels with cements and whatnot. I wonder if in a lot of the wells, you know, I tend to think of the cementing as things you do in a 6,000 or 12,000 foot deep well, and a lot of ours are a lot shallower. But I'm wondering if we were to just come up with a recommendation or whatever, but just sort of a generic, very simple set of steps that we would request for or require for a cement job. Is there anything that is kind of simple and generic that could apply to everyone, with particularly with shallower holes, that maybe would improve? It's not that we have a problem that I see, but just sort of guarantee good results after drilling. And I'm just wondering if you have any sort of simple generic recommendations for us.
Thank you for the question. Yeah, I would reflect back to the slide, which was CAMPS, C-A-M-P-S, and centralization, a minimum of 80%. A, annular fluid velocity, pump it as fast as you can. M, mud properties, make sure that they are as per what the cementing company designed with and haven't changed when it's time to do the cement job. And hole cleaning on that too, 2 times hole volume. Then we would move on to the P. If you're able to move the pipe, rotation's normally easier than reciprocation. And of course, spacer design. Spacer is quite often undervalued, but it's very, very necessary because it helps displace that drilling fluid out of the way. And it also makes that water-wet environment for you to be able to get a good cement bond. So I think the CAMPS, if you're able to apply those best practices to the cement jobs, then that's certainly a step in the right direction. Thank you.
Thank you.
Any questions, additional questions? Hearing none, again, Simon, I'd like to thank you very much for your presentation. It was excellent. I'm sure somebody's going to have a follow-up question or two in the next week. And Todd, I want to really thank you for arranging this. We really appreciate you and Halliburton doing this for us.
Thank you very much, everybody, for allowing us to present. And I appreciate all of your questions. And if there are further questions, it'll be a pleasure to answer them. Thank you very much.
Thank you. Moving on to item 4, Arizona Energy Partners, TA status. Marta or Dennis, which one of you are going to present to us on that?
I'm taking over for items 4, 5, and 6.
Okay.
Arizona Energy Partners currently has temporary abandoned status per the commission at the last meeting, 15th of May, which expired the 13th of August. The commission asked for some information that would conclusively convince the board that there was
Dennis, I'm having trouble hearing you.
Okay, is anybody else having trouble hearing me also? I'm speaking right in.
No, I can hear you.
You were a little muffled, Dennis.
Okay, I'll take it off of speaker. Does that sound better?
Yes.
Yes.
Much better.
Okay, to start over, so Arizona Energy Partners currently has temporary abandonment status extended through the 13th of August, pending receipt of what would satisfy the board as a demonstration of future beneficial use. On the 15th of July, we received data in regards to perforations and correlated with those perforations sample horizons in the well that show some interesting results, mostly with helium. And I have recommended to the commission that they opt for one of 2 approaches to continuing temporary abandonment status. And so at this point, I turn it over to the board for discussion and a vote.
Commissioners, discussion, comments, questions?
Yeah, this is Dale. I think that the data presented, the chemical analyses and the information relative to the perforation zones and all of that, I think that adequately supports a reason for temporary abandonment. Yes, for temporary abandonment. So I would move to grant that.
Do we have a second? No, we haven't made a motion yet. We're still on the discussion. So if you could
Well,
wait on the
that was my motion.
Oh, okay. Well, let's finish
Then
having.
we can discuss. Then we can discuss the motion.
Okay. Is there anybody from Arizona Energy Partners here? Is there anybody?
This is Jay Scarden. Oh.
Yes.
This is Jay Scarden. I know it was a motion to extend, but I did not pick up a time frame. I did not for the extension.
There was no time frame and there was no second yet.
I would.
Okay.
I'll amend my motion to extend that for 1 year.
And again, this is Jay Scarden. It's 1 year from what date? I'm just pointing out that the motion has to be specific in its time. And 1 year is more specific, but it's 1 year from what date is what I thought that was.
Ask Dennis that.
mentioned.
Ask Dennis from the last expiration date of the approvals.
Okay.
Is there any more discussion from commissioners?
Dennis, can you ask Dennis to define that date?
Yeah, Dennis, what is that date specifically that expires?
The date of temporary abandonment currently that it's in expires August 13th. I presented the commission with two options, either today's date or August 13th to commence the next 1 year TA status.
So Dale, you're saying that your motion is from the August date for 1 year?
Yeah. Well, you've confused me now. I thought he said August 13th.
He did. So is your 1 year from the August 13th date?
That's my motion.
Okay. Is there somebody here from Arizona Energy Partners that wants to speak? Okay, hearing nobody, do we have a second to Dale's motion?
Bill, second.
Okay, all in favor, say aye.
Bill, aye.
Aye for Dale.
Stephen Cooper votes aye.
Frank Thorwald, aye. Item 4, they have their year. Moving on to number 5, rare earth. Administrator Turner, please expand on this.
Okay, well, I'm not going to read verbatim what's in the agenda there. It's clear enough. But what's been hanging is a plug-in abandonment application for the Rare Earth 28-1. I received a plug-in abandonment application for the 12-1 some time ago. But yesterday I did receive what appears to be, it's not officially approved yet, but what appears to be a complete application for the 28-1. Assuming that it's complete, and I hope to review that as soon as possible, then Rare Earth can get busy and plug and abandon both the 28-1 state and the 12-1 state. They're both on Arizona state lands. The commission had authorized me to give a due date of July 31st. Is Mr. Haycraft on the phone?
Yes, I'm here.
Okay, did you have anything further to add, and would you like to discuss any future plans you have after you plug these two wells?
Well, I don't really have. I guess the only thing I would like to add is I wanted to move my rig out there and use my rig to plug these wells, because the cost of plugging these wells is so extraordinarily high in your part of the country there in Arizona, and I can save a tremendous amount of money by doing that. And it's, with the hit we've kind of recovered now, but the hits we've taken, with the oil industry is just almost put us out of business this year. Now we've got our legs back under us again and everything. But I don't want to absorb that, that the high cost of contracting out the job. So I mean, I know the deadline is right around the corner to get started, but is there any room for any, any other short extension to that deadline so I can, move my rig out and be able to take advantage of that cheaper price, get it done?
What date are you proposing?
Oh, I mean, not more than, the most, 30 days is about, instead of the July 30th, August 30th.
Marta Hoden, alternate administrator. I'll soon introduce you. But anyway, Marta, do you have any comment about that? Any input?
No, I think that that's understandable given the unforeseen circumstances right now.
Does any of the commissioners have anything to add to that? Not asking for a vote, just discussion.
Well, I think that's adequate. I don't know if they could do it within that 1 month period of time, but I would approve that, a motion to approve that. I mean, I would propose a motion to approve that.
Dale, this is Frank. Would you go ahead and make your motion, and then we'll let you have some discussion on the motion.
Well, I think it's reasonable to give them the additional time required to move their own rig on site. That's just discussion of what I propose to be a motion. So I would move to grant them, I think Dennis recommended, I'm sorry. I think they recommended 1 month would be adequate to do the job. So I would move that we approve the delay of the plugging and abandoning order for a period of 1 month, beginning with this date.
You want to be specific to August 30th, 2020?
Are you asking Brad? Are you asking me?
No,
Brad,
no,
hey,
I'm
Brad?
asking Dale Nation. Dale, do you want to?
Whatever they say they can meet, whatever requirement they need to use their own equipment to get this done. I say that we should give them the approval, and if it's August 30th that they're recommending that they're asking permission, then I move that we approve that.
Brad, Frank Thorwald, Commissioner Thorwald, August 30th work for you?
Yes, sir.
Okay. Dale, I second your motion to give Rare Earth an extension of 30 days to August 30th to plug and abandon the 2 wells, 28-1 and 12-1.
Thank you, Frank, for clarifying that. Yeah.
Do I, all in favor say aye? Is there any further discussion? All in favor say aye.
Bill, aye.
Aye.
Commissioner Cooper, aye.
Commissioner Thorwald, aye. The motion carries. You have your extra 30 days, Brad.
Thank you.
Moving
Thank
on
you.
to item.
No. I was Dennis, Mr. Turner had asked me about commenting on any other future drilling plans. Do you still want me to do that?
I'd like to hear that. Yeah.
Go ahead.
Okay. Well, in short, right now we've got two prospects that we're trying to get started. Drilling, and at least get started by the end of the year. And that's one well out just east of the town of Woodruff. And then another well, which I haven't even started, I haven't done an archaeological survey or anything on, which is up in, I hate to really get too specific about where it is right now, but it's Navajo County, let's see, just east of Hallbrook. East of Hallbrook, in between Hallbrook and at Amana.
Thank you, Brad.
Outside of, okay, yes, sir. Thank y'all.
Moving on to item 6, report by the Oil and Gas Administrator.
Okay,
Dale,
so the first
sorry, go ahead, Dennis.
first item on the agenda here is Pollard Helium 36-1. Without reviewing the sordid history of this well, we had finally gotten to the point where it needed to be appealable agency action. And upon advice of council, actually extended it another 10 days. So the expiration of all that and the operator's chance to appeal the decision to take over control of the bond and plug it ourselves expired on the 7th of July. I had conversation with the bond company this morning to tell them that we would be moving ahead and inform the bond company that there's 2 options, that they're more interested in having control over the say of who might be going to plug and abandon the well. It gives them a little more control and also gets the job done quicker. I indicated that there is a company operating in the area this summer that could likely do the job, and so I'm going to be sending Lexon Insurance more details about how to contact the Pollard Helium folks and related correspondence and so forth. So we're moving forward on that. Pinta South Operating Company, I heard it.
I have a quick question on that, Dennis. Has Pollard come back to you at all with any kind of communications?
The only response, I have 2 emails for Pollard. Pollard Helium's official email, which I was told they're going to fix, but they never did. The only response I ever get to any emails I send to Pollard Helium is a bounce. But I do have an alternate address of Charles Pollard at a Gmail address, and I've been sending notices to that as well. But no, I don't get any phone calls, no nothing.
Thank you.
And we've sent return receipt requested letters. That's why council advised me to wait an additional 10 days to make sure the surface mail got to the operator in time. And the address of record I've been using, because the official address that was on the organization report form was a different address, that mail got returned, but I was using an alternate address that I pulled off of the Arizona Corporation Commission website, which apparently is the official address of record that they registered the company with to do business in Arizona. And that mail has not been returned. So I'm assuming that they're getting it.
Okay. I have a quick question for Jay with regard to this item. Dennis had indicated he was going to give them the name of a company. Would it be, knowing government shouldn't take sides with any company, would it be appropriate if Dennis just gives them a list of companies, or how does it matter, Jay?
Well, in this case, my understanding is that there's an operator who can do it cheaper, who's going to be out there. He can suggest that to them, but if it's the bonding company's decision. I don't see it as favoring, it's a specific circumstance that I would be in favor of telling the bonding company that there's someone out there they can contact who could do it cheaper. And it's also to the benefit of Pollard's. If this guy can do it cheaper, it takes less of their bond and prevents the commission from having to sue for the balance if the cost goes over the bond.
Thank you, Jay. Sorry, Dennis, if you could proceed, I appreciate it.
Okay, so Pinta South Operating Company has received a few more permits since I last spoke to the commission, and they've actually maxed out their bond on the 10 drilling permits they have. I get sundry notices and progress reports. I think drilling is suspended on a couple of their wells. I'm not sure they're completed. Is Wesley Marshall on the phone still? I noticed you were earlier. Sounds
yes,
like you may have hung
I'm right
up.
here.
Oh,
yeah,
you are
I'm
here.
here.
Okay.
Yeah.
Did you want to add anything to the work you've been doing out there, or what your future plans are?
Oh yeah, I think we will be drilling some more wells, so we should be sending in another performance bond for 25,000 so that we can do some more wells. We are heading back out there in a few days to continue to work on the wells that we've started and start a few more. So that's kind of where we are right now.
Thank
And
you.
the wells you have drilled, are they in temporary abandonment status? We're coming up on the 60-day thing that we have to navigate. Do you have any plans for those wells you've already drilled, finished drilling?
Well, some of the stuff is involving our geologists looking at the sands in more detail. That's what we're waiting for them to finish up going through all the rocks. Dennis, I need to work with you on how to properly navigate, to tell you the truth, for the 60 days. I need to know how to do that correctly. As far as what I need to put in place and that kind of stuff. Because I know that for some of them we will be going over the 60 days.
Yeah, and that's fine. You're taking the right first step, was just keep in communication with me. That's the main thing. I understand that 60 days is almost impossible task, given the logistics of moving equipment from out of state for most everybody. I don't know where that 60 days came from. That part of the rule is very old. But yeah, we can talk more. Appreciate the input. So
Yes.
Desert Mountain Energy also is out there drilling. They've drilled 2 wells, been permitted and drilled 2 wells. They've had some interesting results. Is Mr. Robert Rolfing still on the line?
I am.
Did you want to add any pertinent details to what you've discovered so far? I think, as I understand it, you've completed drilling on both wells. If I'm
We have.
correct.
As of 12:37 p.m. today, we pumped the plug on the cement on the second well on production casing.
Okay, good.
And on the first well, as you and I had briefly discussed, kind of going back real quick on what we had said we would do, we encountered numerous highly porous freshwater zones with low pH, and we made a decision that I said I would do originally, and we would individually cement and isolate each individual zone if it was greater than 10 foot in thickness. And we have done that. On the first well, we isolated 5, and on the second well, we isolated and cemented 4. On the first well, we actually, in between freshwater zones 3 and 4, there was a very high alkaline. It was off the chart, very odd alkaline. It was not salt per se. It was not sodium, was not potassium. There's some other odd things going on out there. And it was very high porosity, and it was flowing, and we made the decision, and we actually squeezed 548 sacks of cement into that formation all by itself. It was extremely, it actually flash set the cement. So I made 1 fence post out of 1 drill pipe. We recovered it, but it flash set. So getting back to what Mr. Simons had said earlier, part of both our wells and my design on these wells, one of his basic problems that everyone runs into is if you're using heavy spud muds or very heavy muds to try to get through all these water zones, and you have the inherent problem of not only lack of hydrostatic head, but you also have the problem of just so much water coming at you. So we chose to drill with air and stay away from the mud filtration and the filtrate on the walls. And we were successful. Yes, it costs a lot of money, but that's what I told a lot of people, and also told Mr. Turner that we're going to do to protect the freshwater zones. And that's what we did. We were successful on it. We had some very interesting flows from some, on the first well, we had flows of gas from 5 different zones. We haven't done testing on them individually, so I'm not privy to say exactly what they were. But there are some very promising signs to it. We're not looking at CO2. I'll just put that out there. We're looking at something a whole lot easier to deal with, along with the helium. And on the second well, we had some very interesting flow rates. And basically, each first well number 1 was to encounter an anticline. We came in on each intended pay zone. We were plus or minus about 3 feet. On the second well, it was a domo structure, and we hit everything within one foot, plus or minus, of what our seismic showed. So I was pleased. It doesn't always work like that for drilling wildcat. So I'll just say, thank you, Lord, and pass the ammo, and we're looking forward to doing more. We will be completing those wells in about a month because I used premium light cement, and there's some other stuff to deal with. A lot of what Mr. Simons, it's been a lot of years since I had the privilege of working with him. It's been about 22 years exactly, and that was in Malaysia that I last worked with him and Halliburton on the well. So I have not, it has not been lost on me what I have learned over the many years. So I appreciate that. Although a lot of what he had to say dealt with more oil, and gas can have some odd properties, especially if you're dealing with CO2 versus nitrogen. There are some very unique properties that happen to cement, and there's some things that we did to address that when we were pumping. So, yes, accelerants and deaccelerants on different stages. It was unique, and I'm just glad God gave me a brain and I hadn't forgotten how to use it. So other than that, that's a quick version, gentlemen, and we're looking forward to permitting a couple more wells and drilling 1 or 2 more wells in the third quarter or the fourth quarter of this year. Any questions, gentlemen?
So I want to add a reminder here, Robert, that we respect and we recognize the confidentiality, and you're not obligated at all to say anything on the phone here, but the rule does require that you submit any testing data, logging data, and so forth and so on within 30 days after you complete that work. So just keep mindful of that. You're guaranteed per the rule 1 year of confidentiality, and you have the option at the end of that time to extend it if you want. But just be mindful of any test results that you have or any logs that you send them to me.
And that is correct. And that is that applies to things where you have my understanding from your counsel originally was that applies to things where you have chain of custody and a proper, when you do not have what would be API standards for gas testing, that would not apply because they do not have all the preset requisites to a test that would stand either for any of the exchanges, SEC, TSX, Tron, VSE, CSE, or Frankfurt exchanges, which is where we trade on. Doesn't meet those requirements, and it's just strictly a research tool. I'll just throw that.
Are you saying that you're not going to submit the test results, or are you saying that they will not be deemed confidential?
When we perforate and send it out, because the testing that was done on the gas was not done in a manner that would meet all the requirements, and therefore they are subject. Just to give you a quick idea on this, Dennis, when you're trying to take it off a 5-inch bluey line that you've just finished blowing 1,100 CFM a minute down, you still have a lot of air out there, and you're just looking for background. And the background off air is, at that altitude is 73.172% nitrogen by volume and 23.17 or 23.156% oxygen by volume. So when you get test results back that show a lot of O2 in it, you automatically know that you're not truly getting a formation test, and therefore you're just getting, in general, do you see anything out here on the chromatograph and spectral analysis? So it doesn't stand. It wouldn't stand in court, wouldn't stand with any exchange, and that's why we haven't said anything. It's a helpful tool, like going out and picking up a rock and looking at it. If you're trying to do an assay, that's some great Criscola or something else, but what's it really? I can do a hand assay on it, but it doesn't meet the requirements for all weighed and balanced and sampling and chain of custody. That's why. It's just an additional tool. I guess does that make sense? It's just an additional tool to try to tell me am I looking in the right direction or am I totally off in left field?
Okay, so I'm interested in comments from our council, but also from the new administrator, Marta Hoden, what your take is on what he was just saying in regards to whether we submitting data or not.
Dennis, this is Jay. I will not comment at this time. If you want to deal with this further, we can deal with it later offline.
Okay.
Let's just move.
Anybody else have any comments?
This is Commissioner
Just
Thorwald.
move on.
We're wasting time. Just move on. We can deal with it
Okay.
on a separate call.
Okay, well, just a quick word on Prize Energy Resources. I know that they're going to be public noticing their aquifer protection permit, area-wide aquifer protection permit that resembles Ranger Development's aquifer protection permit from about 2 years ago. That public notice date is later this month. I don't remember specifically. I'm not sure if they've actually fixed that date, but it'll be later this month for an APP permit. And that's about all I have to say about Desert Mountain. In regards to the Lean Performance Board, this has been an ongoing program to develop something that can be viewed online instead of just a physical sheet of paper on the board at ADQ's office. And we have a performance board and a flow board that commissioners will be able to access online using a real simple software called Trello. And we'll be showing commissioners in the future how to be able to look at progress of drilling projects or progress of special projects, rule development, whatever everybody decides to put on there. So that's a thing to be coming in the future. Finally, I want to introduce Marta Hoden.
Dennis, one moment. Just to let everybody know, I've been using that, looking at that now for a number of months. It was just developed last year, and it should be a good tool for everybody to keep track of what's going on a ongoing basis, and to be able to assist and help with suggestions to Marta. Go ahead, sorry.
Finally, I just want to introduce Marta Hoden, who will be the new administrator replacing me. We're transitioning from me to her. Pretty much moving forward, she'll be your point of contact, and I'll be like support staff for her through the end of next month. Marta has 5 years of professional experience with a few different oil and gas companies, mostly in Houston. She's also worked for companies in Denver. She has a master's degree in geology from the Colorado Sewell Mines and a bachelor's degree from Towson University in Baltimore. And she came on board at the end of June, and she'll be replacing me, like I said, by the end of next month. And that's the end of my report.
Very good.
Welcome,
Marta.
Marta. Dale, this is Dale. Welcome, Marta. We look forward to working with you.
Thank you, Dale.
This is Commissioner Thorwald, and I've got to remember to always say introduce myself on these things because I forget to. But I've been working with Marta now for the last few weeks, and after she got through her training, and she's been a delight to work with. I think we'll have good things moving forward here.
Thank you, Frank. I'm really excited to be here.
Moving on to item 7, the Coconino report by the chairman. The Coconino Plateau Water Advisory Council. Dale and I, along with some people from DEQ, spoke to them, and I think you've all were sent a copy of the video recording of the session that was there, and we've got some follow-up questions that we've been working on to answer that, and before that goes out to them, everybody will get a copy for any additional input. DEQ, Marta and Dennis and Dale and I have been working on the answers to those questions, and I'll just move on from that. Does anybody have any questions about that? Let me move on to the legislation regarding that. Right now, I'll answer two. There's no legislation going on per se right now that is inactive. We've been continuing to try to reach out to legislators in both the state Senate and the House to communicate with them. We have briefed several in the Senate and in the House. However, there's a number of legislators, both in the Senate and House, who I am still trying to communicate with and have been trying to for almost 2 years. And I've just tried extensively again to reach them, their staffs, and so forth. And I have yet to receive any communications back asking us to give them a briefing on anything. So that's not proceeding very well. I see they're still out there. A lot of these legislators are still out there saying information about hydraulic fracturing and all the other kinds of things that we've heard in the past, but most of it is misinformation, and they've not been well informed. So I'm going to continue to try to reach out to them to be able to give them the proper information that they need to have so they can make wise decisions. Any questions there? Hearing none, let me move on to the website redesign. The website, we have a meeting on Monday with the communications people. What we are doing is we're going to be adding a section on a newsletter that maybe weekly, bi-weekly, we'll have yet to see to determine how often it comes out. Something that talks about helium in Arizona, a number of other things, additional links that people can go to, information on what the commission has been doing. These videos from our meetings will be available online. Also, I'd like to get a small bio from each one of the commissioners and their pictures so that we can put that up online as well. So we're in the middle of that as well. The web portal, which is separate from the redesign and additional information for the website, it's the automation process. We're still in the works with that. We're in the process of getting from the IT department bid specs so that we can not go out for bid yet, but do some additional informal inquiries with regard to cost of each of the sections. And that's where that should be done shortly. Any questions on that? Moving on.
Yeah.
Go ahead.
Question came up. This is Dale. Question came up in the Coconino conference that we had about people that are concerned about their property use and so on. Would like to have some advance notice whenever there is
a company coming in and leasing property, getting oil and gas leases that might affect local property owners. Now, will this kind of information be available on the website?
That's what we're looking to have up there as well, yes. And in fact, that's a good point, Dale. If you or any of the other commissioners have recommendations, please get them to us ASAP, because we're going to be having these discussions, as I said, on Monday. And hopefully we'll have some of these changes done within the next week or two. So
yeah, I think whatever the first indication of a company's interest in property should be available to the public. And now I cannot answer the question that it would be, but if we could have a section on the website, say current activity or proposed activities, something under that kind of a heading to make it available to the public if they want to access the website. I would suggest that we include that. And that may go to Marta, or maybe go to Dennis, or to yourself.
Fantastic. Thank you. Thank you, Dale. With that in mind, and I'll go back, regress here at the website for a second. I have spoken with the division director that we work with there at State Land, and asked him to send me some links. I haven't gotten the links yet, but I'm going to give him a ring back about that, and to add links to a variety of different things. So we're working on that as well. Going on to budget, we have been involved with the budget with the DEQ, and they've kept us clued in on that, our budget that they've estimated, and it's really an estimate, and they've informed us that it may change given the financial issues going on with the state and the COVID-19 issues. Now, we do have a certain amount of money that we expect to be set aside, as I've mentioned before, for the portal work, and we're looking at a variety of other mechanisms to potentially raise additional funds to finish all the other work up sooner than later. And I will keep you posted on where we stand with that. The rule updates. Dennis and Marta and I participated in a Governor's Regulatory Review Council training session this morning. That was the reason for delaying the meeting till this afternoon on rule updates, 5-year reports, so we can move forward with that. And we still do not have the rest of the stuff from the AZOGCC. They have been delayed like everybody else has because of the virus going on, but hopefully we'll get that and still be able to get this in before the end of the year. I'll give you an update on that at the next meeting. And with regard to the procedures manuals, now that Marta is on board, Dennis is focusing on getting that done, and Marta will be following through with that, with whatever Dennis has not completed, and putting it in online manuals for everybody as we move forward. Any questions about any of those? And as I mentioned before, there is no legislative activities going on right now that affect the commission. We have also, I would put out, we've started as of yesterday getting the newsletters from DEQ, which I shouldn't say they're newsletters, but they're an advisory on news articles that are out there. And it includes oil and gas types of things that come across our table. and we will get more of those as we move forward, and that might be something we can look at with the putting on the website as well. That is all I have to report. Any other questions before we move on to item 8, call to the public? Moving on to item 8, call to the public. Is there any members of the public that would like to say something? If there is,
Robert
please.
Rolfing.
Robert, go ahead.
Just getting back to Dale Nation's little comment about wanting to have the public notified. My question would be for council to review, not necessarily instantly, but for the public to be notified if, in our case, we're a public company, and if we're just out looking at property and try to acquire property, we would be required by exchange rules to do a press release, and that could be detrimental to the company, to the price that we'd be paying, and to the shareholders. And it would not, it would provide an avenue, a possible avenue for insider trading, and I would just urge a caution and review before that type of an adoption would be put in. Other than that, thank you.
Thank you for your comments. Appreciate that.
Yeah, this is Dale. Yeah, I definitely.
Dale, remember, we cannot respond to him.
Oh, you're right. I'm sorry.
Sorry. Any other members of the public which wishes to say anything? Hearing none, let's move on to item number 9, review and consideration of future agenda items. Is there any items that we need to put on the agenda for our next meeting that we haven't already discussed? Hearing none.
I move for adjournment.
I second that. All in favor, say aye.
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 The motion carries. We're adjourned. Thank you all.
All right, thanks, Frank.